Now I am starting chapter 2, inverse trigonometric functions. Dear students, we discussed about 6 trigonometric functions. Main functions are sine, cosine, tan, cot, sec and cosec. So domain, codomain, range, their graphs, everything we discussed in 11th class. Now in 12th class we are discussing definitions, graphs and properties of their inverse functions. In first chapter we discussed about inverse of function, that when inverse of any function exists, what is required property for existence of inverse, so that we are using here. So we take one by one. First of all, inverse of sine function. First is inverse of sine function. It is sine inverse. Inverse of f, it is denoted as f inverse. So this is notation, sine inverse. Now we know that if a function is 1 1 and onto, then its inverse exists. Now we know that function sine is a function whose domain is R, codomain is R. We know also its graph. Its graph is like a wave shape. This is a graph of sine function. Here 0, pi, 2 pi, 3 pi, minus pi. This is y-axis, this is x-axis. This is graph of sine function. If we draw any horizontal line, means a line parallel to x-axis, then it is clear that image of this point, image corresponding to this point, image corresponding to this point are same. Here, if this number is x1, here point is x1, then its y coordinate we take y1. If on y-axis, if you keep here y1, then coordinates of this point x1, y1. If here x value is different, so let me denote by x2, but their y coordinate is same, y1. So this is happening. x1 not equal to x2, but their images are same. x1 not equal to x2, but their images y1 is equal to y2. So this function is many one. It is not 1 1. So to convert this function, because this is not 1 1 function, it is not onto function, neither 1 1 nor onto. Range is also minus 1 to 1. So range is minus 1 to 1. Range is not equal to codomain. And because of this reason, function is many one, it is not 1 1. So function is not 1 1, it is not onto. So its inverse, sine inverse from B to A does not exist. So to find inverse of sine function, for existence of sine function, what we have to do? I have to restrict this domain. If in this graph if I take, say this number is pi by 2, and here corresponding to this point, here x value is minus pi by 2. So here if I take graph of this function, only this part of graph, if we consider, I am restricting domain. See, domain is, now you can see that same graph, same function, but now I am taking domain minus pi by 2 to pi by 2. Domain is minus pi by 2 to pi by 2. So instead of its original domain and codomain, now instead of this part, now what we are doing, we are discussing on minus pi by 2 to pi by 2. Instead of R, we are taking this restricted domain of this function. And codomain I am taking here close interval minus 1 to 1. Domain is minus pi by 2 to pi by 2. Codomain is minus 1 to 1. Then on this restricted domain, this will be the graph of sine function. Now if you draw any horizontal line, then horizontal line will intersect graph in only one point. Whenever on given domain, if you draw any horizontal line and if it cuts graph in only one point, that means this function is 1 1. It is 1 1. So here y values, y coordinate of every point. See, maximum value of y is 1, minimum is minus 1. So range is close interval minus 1 to 1. Range of this function is close interval minus 1 to 1. And same is domain. Same set we have taken as domain, codomain. So range is equal to codomain. So range is codomain, function is 1 1. If we restrict domain and codomain, so on this domain and codomain, this function's inverse exists, and its inverse will be from, if f is from a to b, so inverse will be from b to a. So in this chapter, in every function we will restrict domain, we will change the domain and codomain, then its inverse exists. So this was about first function. So sine from close interval minus pi by 2 to pi by 2 to minus 1 to 1, domain, codomain, this function is 1 1 and on 2. Therefore inverse of sine exists, and it is sine is from a to b, sine inverse is from b to a. Now it's a graph of sine inverse. This line is x-axis, this line is y-axis, this is origin. Domain is now minus 1 to 1. Keep here minus 1, here keep plus 1. Domain is minus 1 to 1. Here we are putting limitations. To draw graph perfectly, we are putting limitations. Domain is between these two numbers, minus 1 to 1. Codomain is minus pi by 2 to pi by 2. somewhere here minus pi by 2, at the same distance on upper side plus pi by 2. So graph will be between these two horizontal lines. It will not cross these two horizontal lines. It will be between these two lines. Now graph will be passing from origin. I put this O on this side. These points, it will be passing from origin. It will be something like this. This will be the graph of y equal to, this is graph of y equal to sine inverse x. Y equal to fx, like that. Fx is sine inverse x. Now, properties. See, first property. If theta belongs to close interval minus pi by 2 to pi by 2, then if theta belongs to close interval minus pi by 2 to pi by 2, then sine theta equal to x implies sine inverse x equal to theta. Say this is like fx equal to y, fx equal to y. So on other side what I have written? On other side I have written x equal to f inverse y. Fx equal to y. So x equal to f inverse y. It is allowed when function is 1, 1 and on 2. And here already we have taken domain and codomain accordingly to make it 1, 1 and on 2. So the statement is like this. Inverse of sine is sine inverse. Inverse of f is f inverse. So here inverse of sine is a sine inverse. Now to understand this I am taking example. Suppose we know that sine pi by 6 is 1 by 2. Sine pi by 6 is 1 by 2. Therefore, sine inverse 1 by 2 is pi by 6. This is true. Sine theta is x implies sine inverse x equal to theta, because theta belongs to, if this theta belongs to minus pi by 2 to pi by 2, close interval minus pi by 2 pi by 2, then this is allowed. And here pi by 6, because pi by 6 belongs to close interval minus pi by 2 to pi by 2. That's why this is allowed. Always remember, theta must be in this interval, then and only then you are allowed to shift this sign on other side. Not every time. Second example. Suppose sine of 3 pi by 4 is 1 by root 2. Sine of 3 pi by 4 is 1 by root 2. Now check. Does 3 pi by 4 belong to this interval? This interval is minus pi by 2 to pi by 2. That means here you have to check. If number is theta is positive, it must be in first interval. Theta is negative, then in fourth quadrant in clockwise direction. Minus pi by 2 to pi by 2. On number line this can be seen like this. We need theta in this part. Now see, sine 3 pi by 4 is 1 by root 2. That is true. But if I keep here sine inverse 1 by root 2, it is equal to 3 pi by 4, then this is not correct. because this number does not belong to this interval. 3 pi by 4 is somewhere here. 3 pi by 4, it is more than pi by 2. It doesn't belong to this interval. So because 3 pi by 2 does not belong to this interval, this implies sine inverse 1 by root 2 equal to 3 pi by 4 is not true. So here I am putting statement, this is 1 by root 2, but sine inverse 1 by root 2 is not equal to 3 pi by 4. Because 3 pi by 4 does not belong to minus pi by 2 to pi by 2. Sine of minus pi by 3, sine of minus pi by 3 is minus root 3 by 2. Now check this number. It must be in this set. If theta belongs to domain of sine, say here sine function is working, it must be in domain of sine. Domain of sine is close minus pi by 2 to pi by 2. Minus pi by 3, check existence in this set and it is clear. Minus pi by 3 is somewhere here. Somewhere here. It belongs to this set. Therefore, here sine inverse minus root 3 by 2 equal to minus pi by 3 is true. Reason is because minus pi by 3 belongs to close interval minus pi by 2 to pi by 2. So this is the meaning of first property. Now second property. Second property is also similar. If theta belongs to minus pi by 2 to pi by 2, means if theta belongs to domain of sine, then and only then sine inverse sine theta equal to theta is true. It is not like that sine inverse and sine is cancelled. These are not reciprocal of each other. It is composition of two functions, f inverse of fx. So say, to understand this property, I am taking a value of theta. I am putting theta equal to, suppose theta I am putting pi by 12. Sine inverse sine pi by 12 equal to pi by 12 if pi by 12 belongs to this set. And yes, pi by 12 is somewhere here in first quadrant. So this is equal to pi by 12 is true because pi by 12 belongs to minus pi by 2 to pi by 2. Sine inverse sine of minus pi by 6 equal to, now check minus pi by 6, it must be in domain of sine. See, inner is sine. On minus pi by 2, first of all sine is working. On theta, machine sine is working. So this theta should be in domain of sine. That is close interval minus pi by 2 to pi by 2. Domain of sine, close interval minus pi by 2 to pi by 2. Very important. These two lines are very important. So minus pi by 6 is somewhere here. It belongs to this interval. So this is equal to minus pi by 6. It is true because minus pi by 6 belongs to close interval minus pi by 2 to pi by 2. Sine inverse sine of, suppose I take here pi 7 pi by 4 Sine inverse sine 7 pi by 4, it is not equal to 7 pi by 4, because 7 pi by 4 does not belong to minus pi by 2 to pi by 2. So this is the application of this property. By this way we apply property. Third property is sine of sine inverse x equal to x if x belongs to, see on x which function is working, sine inverse is working. On x sine inverse is working, so x should be in domain of sine inverse. What is domain of sine inverse? Minus 1 to 1. So x on x, this is working, so x should be in this set. So this is allowed if x belongs to close interval minus 1 to 1. As for example, sine of sine inverse 1 by 3 equal to 1 by 3. It is true because 1 by 3 belongs to minus 1 to 1. But if I keep here sine of sine inverse 4 by 3, now this number does not belong to this set. 4 by 3 is not in this set, minus 1 to 1. So this is not equal to 4 by 3 because 4 by 3 does not belong to minus 1 to 1. So that is it, meaning of this third property. Then fourth property, say sine inverse x, it is not 1 upon sine x. It's not, this is not power, it's a symbol, f inverse. We know that f inverse is not 1 upon f. So don't consider this as 1 upon sine x or sine inverse x. This also cannot be expressed as sine x raised to minus 1. It is not allowed. So this was about sine inverse. Now we are taking next cos inverse. Now second is inverse of cos function. Inverse of cosine function or cos function. It is denoted as cos inverse. As discussed in sine, we know that domain of cos is R, codomain is also R. If we draw graph of this cosine function, we discussed in 12th class, its graph is something like this. This is graph of cosine function. Here also, if we draw a horizontal line, then it cuts graph in many points. That means image of x1 and image of x2. See, x1 and x2 are distinct, but their images are same. So this function is not 1, 1. Its range is minus 1 to 1. Values are oscillating between minus 1 and 1. So range is close interval minus 1 to 1, while codomain is R. So range is not equal to codomain. So this function is not onto. Function is neither 1, 1 nor onto. So its inverse does not exist. So for existence of inverse of this function, we have to restrict the domain. So say here, we will restrict domain till this number, till this point. Here number on x-axis it is pi. So what we are doing, if I take only this part of graph, on this side I am removing completely on left side of y-axis. If we take domain 0 to pi, then in 0 to pi, this is the part of cosine function. And here, if you draw any horizontal line, it cuts curve in one and only one point. So this function is 1 1. If we restrict domain, now restricting domain 0 to pi, this is restricted domain, then function is 1 1. If we take codomain -1 to 1, then range is also same, -1 to 1. So range is codomain and function is 1 1 in this interval. So on this domain and codomain, cosine is 1 1 and on 2, so its inverse exists. And its inverse will be from B to A. So that is the next point. Cos function 0 to cos function, domain if 0 to pi, codomain is -1 to 1, then it is 1 1 and on 2. So cos inverse exists, and cos inverse will be from B to A. Graph of cos inverse. So here, this line is x-axis, this line is y-axis. X and y-axis. Here origin. Domain is closed interval -1 to 1. So for a domain, here this number is -1, this number is +1. So graph remains between two vertical lines, x equal to -1 and x equal to 1. Range is closed interval 0 to pi. This is x equal to 0. Suppose somewhere here this number is pi, so it is x equal to pi. Between 0 and pi, somewhere here there will be pi by 2. So graph will be from beginning from this point, passing from this point, it will reach at this point. So something like this. So this will be graph of y equal to cos inverse x. This is graph of y equal to fx. You can see that function is lowering down, moving from left to right, function is lowering down. Now properties. As discussed properties, similar properties for cos inverse. Here domain of cosine is 0 to pi. So if theta belongs to 0 to pi, if theta is in 0 to pi, then cos theta equal to x implies theta equal to cos inverse x is allowed. Very important property. On theta, cos is working. So theta should be in domain of cos. And domain of cos is 0 to pi. Say, here on number line, this is 0, this is pi. So 0 to pi. So theta should be this part. On number line, 0 to pi, it is via pi by 2. So theta should be in this interval. As for example, suppose if I keep here cos of pi by 5 pi by 6, cos 5 pi by 6 equal to cos 5 pi by 6 is cos of pi minus pi by 6, that is minus cos pi by 6, that is it is minus root 3 by 2. Cos 5 pi by 6 is minus root 3 by 2. This is correct. Implies, now this number I am taking on this side. So cos inverse minus root 3 by 2. Cos inverse minus root 3 by 2 equal to 5 pi by 6 is correct. Because this number, it belongs to 0 to pi. 5 pi by 6 is somewhere here. It belongs to 0 to pi. That's why this is allowed. Now, if I take cos of 7 pi by 6, cos of 7 pi by 6 is pi plus pi by 6. So minus cos pi by 6. Same value, minus root 3 by 2. But here if you take this number on this side, then cos inverse minus root 3 by 2, if you put 7 pi by 6, then this is not correct. Cos inverse minus root 3 by 2 equal to 7 pi by 2. These are not equal, because this number does not belong to 0 to pi. 7 pi by 6 does not belong to 0 to pi. 7 pi by 6 is somewhere here. It is more than pi this side, while this number was in 0 to pi. So it was allowed. Cos of minus pi by 3 is 1 by 2. Cos of minus pi by 3 is 1 by 2. Minus pi by 3 is somewhere here in this direction. It is negative value. Cos minus pi by 3 is 1 by 2, that is correct. But if we take cos inverse 1 by 2, if you take cos on this side, then cos inverse 1 by 2 equal to minus pi by 3 is not correct. These are not equal, because minus pi by 3, it is negative, and this interval contains all positive. Minus pi by 3 is on this side, so not allowed. That is meaning of this property. Second property, if similar property, theta is in 0 to pi, then and only then sine cos inverse cos theta equal to theta. This is true. Again on theta, cosine is working. So this theta must be in domain of cosine. Domain of cosine 0 to pi. As for example, cos inverse cos of pi by 6 equal to pi by 6. It is true, because pi by 6 is in domain of 0, a domain of cosine function. Pi by 6 is somewhere here, or on unit circle somewhere here, because pi by 6 belongs to 0 to pi. cos inverse cos of, if I take 5 pi by 3, this is not equal to 5 pi by 3, because 5 pi by 3 is more than pi. Somewhere here 5 pi by 3 will be somewhere here. It will be somewhere here. 2 pi minus pi by 3. So this is the point corresponding to 5 pi by 3, more than pi. So cos inverse cos 5 pi by 3 is not equal to 5 pi by 3, because 5 pi by 3 does not belong to 0 to pi. So this is the meaning of this property. Third property, cos, now outer is cos, inner is cos inverse. Cos of cos inverse x equal to x. If x belongs to, now see, on x which function is working? Cos inverse. On x cos inverse is working, so x should be in a domain of cos inverse. And what is domain of cos inverse? Minus 1 to 1. So x should be in domain of cos inverse, that is minus 1 to 1. So see, these two lines are very important. Domain of cos is 0 to pi, domain of cos inverse is close interval minus 1 to 1. As for example, cos of cos inverse 5 by 6 equal to 5 by 6. It is true, because 5 by 6 belongs to minus 1 to 1. But if I keep here cos of cos inverse 6 by 5, then this is not equal to 6 by 5, because 6 by 5 does not belong to minus 1 to 1. That is third property. Fourth property is cos inverse x. It does not mean 1 upon cos x. It is not sec x. Or cos inverse x, it is not cos x raised to minus 1. Not equal. So this was about cos inverse. Now third function is inverse of tan function. It is denoted as tan inverse. As discussed in case of cos inverse and sin inverse, here also we are restricting domain. Say tan function, if it is defined on open interval minus pi by 2 to pi by 2, if it is defined on open interval minus pi by 2 to pi by 2, say this is restricted domain. Original domain of tan was r minus 2n plus 1 times pi by 2. N belongs to z. So this was original domain, and its codomain was r. But on this domain, on its original domain, function is not 1 1. It is on 2, but not 1 1. But if we restrict domain, if we take this part of domain, then and codomain r, codomain we keep as it is, because on codomain r it was on 2, so keeping r as it is. So this function is 1 1 and on 2. Therefore its inverse exists, and it is tan inverse Now A to B, it will be converted into B to A. Now see, graph of this function, graph of tan inverse, domain is R, codomain is minus pi by 2 to pi by 2. This is x-axis, this is y-axis. See, range is open interval, here it is open, not close, minus pi by 2 to pi by 2. So graph will be between these two horizontal lines. Range is open interval minus pi by 2 to pi by 2. Domain is R, so its graph will be something like this. Moving from left to right, it is rising up. Here going in upward, going near and near towards this vertical horizontal line, y equal to pi by 2. Distance of this line, horizontal line, and this graph, it will be continuously decreasing, but they will never cross, never touch. Similarly at this side. So this is graph of y equal to tan inverse x. Now properties. First property, see, there is a similarity in domain of sine and domain of tan. Domain of sine was close interval minus pi by 2 to pi by 2, and here open interval minus pi by 2 to pi by 2. That is only the difference. So if theta belongs to open interval minus pi by 2 to pi by 2, if theta is in domain of tan, then x equal to tan theta implies tan inverse x equal to theta. If theta is in this set, domain of tan, then this tan theta equal to x implies tan inverse x equal to theta. This tan, it will be shifted on other side in form of tan inverse. So tan inverse x is theta, but it is allowed if theta is in restricted domain of tan. As for example, tan of pi by 6 is 1 by root 3. Tan pi by 6 is 1 by root 3 implies, now check, pi by 6 is in this set, so this can be shifted. So tan inverse 1 by root 3 is pi by 6. This is true because pi by 6 belongs to open interval pi by 2 to pi by 2. Tan of 7 pi by 6, tan of 7 pi by 6, that is pi plus pi by 6, third quadrant. In third quadrant tan is positive, so 1 by root 3. This is true, but if I keep tan inverse 1 by root 3, taking tan on this side, tan inverse 1 by root 3 equal to 7 pi by 6, then this is not true. It is not true. This is true because this number does not belong to minus pi by 2 to pi by 2. So this is true, but this is not true. So these are not equal because 7 pi by 6 does not belong to open interval minus pi by 2 to pi by 2. Tan of minus pi by 4 is 1. Sorry, tan of minus pi by 4 is minus pi by 4 that is fourth quadrant. In fourth quadrant tan is negative, so minus tan pi by 4, that is minus 1. Tan of minus pi by 4 is minus 1. Now check, does it belong to this set? So it belongs to this set, already the number belonging to this set. Therefore tan inverse, tan shift on this side, so tan inverse minus 1 equal to minus pi by 4. This is true because minus pi by 4 belongs to open interval minus pi by 2 to pi by 2. Difference between sine inverse and tan inverse is that difference of only ends of interval. Here open minus pi by 2 to pi by 2, in sine it was close minus pi by 2 to pi by 2. Second property, similar, if theta belongs to open interval minus pi by 2 to pi by 2, then tan inverse tan theta equal to theta. This theta should be in domain of sine. See, on theta tan is working. This theta should be in domain of tan, because on theta tan is working. So theta should be in domain of tan. It is minus pi by 2 to pi by 2. As for example, tan inverse tan of minus pi by 3. Now check, does it belong to this interval? So it belongs to this interval. So this is equal to minus pi by 3, because minus pi by 3 belongs to open minus pi by 2 to pi by 2. If I keep tan inverse tan of 2 pi by 3, does it belong to this interval? 2 pi by 3 does not belong to this interval, so this is not equal to 2 pi by 3. It is not like that tan inverse and tan, wherever you get it will be cancelled. We are not cancelling here. By property, put every value. This is not equal to 2 pi by 3, because 2 pi by 3 does not belong to open minus pi by 2 to pi by 2. Then third property, here outer was tan inverse, inner was tan. Now I am putting outer tan and inner tan inverse. So tan of tan inverse x equal to x. On x, which function is working? Tan inverse is working. So that x should be in domain of tan inverse, and domain of tan inverse is R. So these two lines are very important. So if x is in R, then this is true. Now R contains everything. So this is true for every x belonging to R. That means tan of tan inverse, if you keep here 1 by 7, it is 1 by 7. Tan of tan inverse, if you put here 7000, then answer is 7000. No restriction, any number x is allowed. Tan of tan inverse x is x. And last point, that is tan inverse x is not equal to 1 upon tan x, or tan inverse x is not tan x raised to minus 1. Now next is inverse of cot function. Inverse of cot function, and it is denoted as cot inverse. Again, cot function, say domain of cot, we know that the domain of cot is R minus n pi, n belonging to z to R. This is domain and this is codomain. On this domain, function is not 1 1. It is onto, but not 1 1. So to get its inverse, we have to restrict this domain. So restricting domain, now we keep restricted domain open interval 0 to pi. This is restricted domain. Codomain is R. Taking this domain and codomain, now it is 1 1 and onto. So its inverse exists, and it is cot inverse R to 0 to pi. So here properties will be like cos function. In topic of cos inverse, we took a closed interval 0 to pi, and here we are taking open interval 0 to pi. So difference is only in endpoints. Domain of cos function includes ends. Here domain of cot excludes ends. Now graph of cot inverse. So here this is x-axis, here this is y-axis. Cot inverse, range is 0 to pi, 0 to pi. So graph will be between these two horizontal lines, y equal to 0, y equal to pi. Here mid value is pi by 2. And here graph of cot will be, it will be something like this. Lowering down. So here this graph moving from left to right, it is lowering down, and it cuts y-axis at pi by 2. Point y coordinate of this point is pi by 2. So this is graph of y equal to cot inverse x. Moving from left to right, lowering down, and as x value of x increases, this graph is coming near and near towards x-axis, but it will never touch, it will never cross, even though distance is continuously decreasing. And same thing is happening on this side. As x tends to minus infinity, graph is going near and near towards this line y equal to pi. So this is graph of cot inverse x. Now properties. First property is, if theta belongs to 0 to pi, 0 to pi, then cot theta equal to x implies theta equal to cot inverse x. If theta is in domain of cot, then this cot, it will be shifted on this side in terms of inverse. As for example, cot of pi by 4 equal to 1. Cot pi by 4 is 1. Therefore, this implies cot inverse 1 is pi by 4, because this is in 0 to pi. So because pi by 4 belongs to 0 to pi, cot of 5 pi by 4, pi plus pi by 4, third quadrant, cot is positive, it is also 1. But if I shift this cot on this side, cot inverse 1, 5 pi by 4, this is not correct. Here cot is not allowed to take on this side. in terms of cot inverse, because this number does not belong to 0 to pi. It is more than pi. So here this is true, but this is not true. So these are not equal, because 5 pi by 4 does not belong to 0 to pi. Second property, similarly, if theta belongs to 0 to pi, then cot inverse cot theta is theta. This must be in domain of cot, that is 0 to pi. Suppose if I take cot inverse cot 5 pi by 6. Now 5 pi by 6 is in 0 to pi. So this is equal to 5 pi by 6 is true, because 5 pi by 6 belongs to 0 to pi. If I take here cot inverse cot 7 pi by 6, but 7 pi by 6 is more than pi. So cot inverse cot 7 pi by 6 is not equal to 7 pi by 6, because 7 pi by 6 does not belong to 0 to pi. Cot inverse cot of minus pi by 6. Now does it belong to 0 to pi? This set contains all positive. This is negative, so not included in this set. So this is not equal to minus pi by 6, because minus pi by 6 does not belong to 0 to pi. That is second property. And third property, now outer function I keep cot and inner function I keep cot inverse. Cot of cot inverse x is x if x belongs to domain of cot inverse. And what is domain of cot inverse? It is R. So this is true for every R, for every real number belonging to R. Cot of cot inverse, if I keep here 0.007, so it is 0.007. This is any real allowed. If I keep cot of cot inverse 10 raised to 22, so it is equal to 10 raised to 22. Because this property is true for every real, here no restriction. And fourth property, cot inverse x is not 1 upon cot x, or cot inverse x is not equal to cot x raised to minus 1. So these are properties of cot inverse. Then next fifth function is about cosec inverse, means inverse of cosec function, and notation is cosec inverse. Here also we restrict a domain and a codomain of cosec function. So if we take domain of cosec, closed interval minus pi by 2 to pi by 2, but in this interval at 0 this function is not defined, so except 0 is excluded. This is domain, and codomain is R minus over interval minus 1 to 1. This is codomain. Domain, codomain. Set of all numbers which are 1 or more than 1, minus 1 or less than minus 1. So from set of all real numbers, open interval minus 1 to 1 is excluded. If we take this domain and this codomain, then this function is 1 1 and 1 2. So its inverse exists. And it is cosec inverse. Now this will be interchange. A to B, then it inverse B to A. So R minus 1 to 1. Now this becomes domain and this becomes codomain. So this is cosec inverse. Now graph of cosec inverse. Say domain is set of numbers which are either more than or equal to 1, less than or equal to minus 1. So here we represent domain as R minus 1 to 1. Suppose that here there is 1 and here there is minus 1. Now function is not defined between these two numbers. So graph will not be between these two horizontal lines. Graph will be outside these two vertical lines. Graph will be outside this vertical lines. So that's why showing here boundary lines. Here we keep limitations, restrictions. For range minus pi by 2, this is minus pi by 2, here this is pi by 2. This is the method. Now see, cosec pi by 2 is 1. Cosec pi by 2 is 1. This is the way, this is the method to remember graph. Cosec pi by 2 is 1. So cosec inverse 1 is pi by 2. This point is included in graph. Cosec of minus pi by 2 is minus 1. So cosec inverse minus 1 is minus pi by 2. This point is also included. Domain is excluding these numbers. So domain is set of numbers which are on this side or on this side. Now, so on this side, graph will be now on this side. So it will be like this. And on this side, from this point, it will be like this. Moving near and near towards x-axis as x tends to infinity. This line is x-axis. So on close interval 1 to infinity, this is 1 to infinity, on this side, curve will be like this. And on minus 1 to infinity, on this side, graph will be like this. So this is graph of y equal to cosec inverse x. Graph is union of two disjoint curves. One part of graph is on right hand side of this vertical line, other part is on left hand side of this vertical line. No any part of graph is between these two lines, because between these two numbers cosec inverse is not defined. So this is graph of cosec inverse x. Now properties, similar statements. First property is, if theta belongs to this set, closed interval minus pi by 2 except 0, then cosec theta equal to x implies theta equal to cosec inverse x. As we discussed in tan inverse, cot inverse, sec inverse, sine inverse, cos inverse, similar properties. Domain of cosec is this set. So number theta should be in this set. Then this cosec is allowed to shift on other side. So theta is cosec inverse x, or this statement can be written as cosec inverse x equal to theta. As for example, suppose cosec of pi by 6 is 2. Pi by 6 is in this set. Therefore cosec inverse 2 is pi by 6, because pi by 6 belongs to closed interval minus pi by 2 to pi by 2 except 0. Cosec of suppose 5 pi by 6. Cosec of 5 pi by 6 is also 2. But cosec inverse 2 equal to 5 pi by 6. This is not correct. They are not equal. Because 5 pi by 6 does not belong to this interval. So this is about first property. Second property, if similarly theta belongs to minus pi by 2 to pi by 2 except 0, if theta is in domain of cosec, then cosec inverse cosec theta is theta. That means these numbers will be cancelled. If theta is in domain of cosec, if I give here cosec inverse cosec of, suppose I put here minus 3 pi by 4, then this is not equal to minus 3 pi by 4, because minus 3 pi by 4 does not belong to minus pi by 2 to pi by 2 except 0. This set, this number does not belong. Cosec inverse cosec of minus pi by 4 equal to minus pi by 4. This is true, because minus pi by 4 belongs to this set, domain of a cosec. Third property, now outer function I give cosec and inner function cosec inverse. Cosec of cosec inverse x is x. Now on x, what is functioning? On x, cosec inverse is working. So x should be in domain of cosec inverse, so it should be in this set. This is true if x belongs to r minus open interval minus 1 to 1. That is, as for example, cosec of cosec inverse 3 by 4. Now can we put this is equal to 3 by 4? So answer is no, because 3 by 4 does not belong to this set. But if I give here 4 by 3, then it is allowed, because 4 by 3 belongs to r minus 1 to 1. Then fourth property is cosec inverse x is not equal to 1 upon cosec x, or cosec inverse x is not equal to cosec raised to minus 1. So this was about cosec inverse. Now sixth function is inverse of sec function. And it is denoted as sec inverse. Again, sec taking restricted domain. Now taking restricted domain 0 to pi except pi by 2, because in this set at a pi by 2 sec is not defined. This is restricted domain, codomain is r minus minus 1 to 1. This is codomain. This function is 1 1 and onto. Therefore, its inverse exists, and it is sec inverse from. Now this codomain becomes domain, r minus minus 1 to 1, and domain is now codomain. Its graph is, say here, this line is x-axis, this line is y-axis, this is origin, here minus 1, here plus 1. So as we discussed, in case of cosec inverse, here also sec inverse is not defined between these two numbers minus 1 and 1. So graph, any part of graph does not lie between these two lines. So graph will be on this side and on this side. Now range is 0 to pi. Suppose here there is pi. So graph will be between these two horizontal lines 0 to pi. And it is not a function doesn't produce value pi by 2. Here I keep pi by 2. So one more line. Pi by 2 is not in range of this function. So here graph is, we can remember by this way, sec pi is minus 1. So it will start from this point. Sec pi is minus 1. Sec 0 is 1. And sec inverse 1 is 0. So it will be like this. See, it will be going up on this side. Similarly, on this side also, from this point, it will be like this. See, distance between this line and this curve is decreasing as x tends to infinity, minus infinity or plus infinity. So this is graph of y equal to sec inverse x. It is graph of y equal to sec inverse x. Properties are similar. First property is, if theta belongs to closed interval 0 to pi except pi by 2, then and only then sec theta equal to x implies sec inverse x equal to theta. This sec will be shifted on this side in terms of sec inverse if theta belongs to domain of sec. So it should be number, it must be number in 0 to pi except one number pi by 2. So here there is similarity in cosine and sec. In cosine we were discussing by taking its domain 0 to pi. Here in sec similar 0 to pi, only difference of pi by 2. Here we are excluding only one number pi by 2. other numbers are as they are, which are in sec. So domain of sec is 0 to pi close here, domain of cos is close interval 0 to pi, domain of sec is close interval 0 to pi except one number pi by 2, and domain of cot, it was open 0 to pi. So in these three functions, cos, sec and cot, there is similarity, and similar examples can be taken. Similar values of theta can be taken. If theta is in this set except pi by 2, then sec can be shifted. Second property, if theta belongs to 0 to pi except pi by 2, then sec inverse sec theta is equal to theta. Sec inverse sec can be cancelled if theta is in this set, otherwise not, as discussed in 5 functions. And third property, outer is sec, inner is sec inverse. Sec of sec inverse x is x. If x belongs to domain of sec inverse are minus 1 to 1. And fourth property is sec inverse x is not equal to 1 upon sec x, or sec inverse x is not equal to sec x raised to minus 1. So these properties also can be understood by taking similar examples, keeping this domain and codomain in mind, as we discussed in 5 functions. So this was about sec inverse. Now, before going on next property, let me discuss about some symbols. Say, if theta belongs to minus pi by 2 to pi by 2, so this means meaning of this statement, and say this is the set of numbers whose modulus is less than or equal to pi by 2. If you take modulus of any number from this interval, its modulus is less than or equal to pi by 2. Then second is, say, so meaning of this both, these are equivalent statements. This implies, double implies this statement. Meaning is same. If you write by this way or this way, meaning is same. They are same statement written in different way. If x belongs to minus 1 to 1, that means this is the set of all numbers whose modulus is less than or equal to 1. So if any question or in any theorem or in any discussion, if this is printed, that means it is set of these numbers. If x belongs to r minus 1 to 1, if x is in this set, means this is the set of numbers which are more than 1 or less than minus 1 or equal to minus 1. More than or equal to 1 or less than or equal to minus 1 means numbers whose modulus is more than or equal to 1. So this was about symbols or sets, meaning of sets in different form. Now explaining formulas. See, first set is cosec inverse x is sin inverse 1 upon x. It is true if x belongs to domain of a cosec inverse. Just I explained, this represents domain of cosec inverse. That means if I keep here 5, then cosec inverse 5, here explanation, see first statement, here explanation is if I keep here 5, so cosec inverse 5 equal to sin inverse 1 upon 5. See, modulus 5 is more than 1. Any number whose modulus more than 1 is allowed to apply this formula. I cannot keep here 1 by 5 because 1 by 5 doesn't satisfy this condition. Second property, sec inverse x is cos inverse 1 upon x if modulus x is more than 1. If I keep here, suppose instead of 5 minus 5, sec inverse minus 5. So minus 5 is allowed because its modulus is more than 1. So sec inverse minus 5 is cosec inverse minus 1 upon 5. Cot inverse, this is for positive. If I keep here say 1, then it will be tan inverse 1 by 7. Now second, sine inverse minus x is minus sine inverse x. Suppose I keep here sine inverse minus 1 by 4. Sine inverse minus 1 by 4 is equal to minus sine inverse 1 by 4. Tan inverse minus 6 is minus tan inverse 6. Tan inverse minus 6 is minus tan inverse 6. Cosec inverse minus 100 is minus cosec inverse 100. Cosec inverse minus 100 is minus cosec inverse 100. So here only the numbers are allowed satisfying condition given inside. Here we cannot keep number whose modulus is more than 1. This represents domain of sine, numbers between minus 1 and 1. Here numbers which are more than 1 or less than minus 1, including 1 and minus 1 also. Here also 1 and minus 1 are included. Then next property, cos inverse minus x. Cos inverse, suppose here minus 1 by 2, x is 1 by 2, 1 by 2 is in this side. So cos inverse minus 1 by 2 is pi minus cos inverse 1 by 2. Sec inverse minus suppose root 2. So sec inverse minus root 2 is pi minus sec inverse root 2. Cot inverse minus 1. Cot inverse minus 1 is pi minus cot inverse 1. So say here whenever minus is inner sign, then we keep here pi minus. And what happens in case of sine inverse, tan inverse and cosec inverse? In case of these functions, minus comes out. Here minus doesn't come out. It comes out, but add here pi minus. Then say sine inverse x plus cos inverse x is pi by 2, means if these numbers are same, then value is pi by 2. These numbers must be same. As for example, sine inverse 1 by 4 plus cos inverse 1 by 4, 1 by 4, 1 by 4, whatever you keep here, same number put here. Sine inverse 1 by 4 plus cos inverse 1 by 4. We don't know what is sine inverse 1 by 4, what is cos inverse 1 by 4. Because these numbers are same, put directly value is pi by 2. Tan inverse x plus cot inverse x is pi by 2. Tan inverse x plus cot inverse x is pi by 2. Here x I have taken 7. Tan inverse 7 plus cot inverse 7 is pi by 2. Similarly here sec inverse 7 plus cosec inverse 7 is pi by 2. Any number allowed belonging to domain of sec inverse and cosec inverse. Satisfying this condition, any number we are allowed to put here. Sec inverse minus 5 plus cosec inverse minus 5 is also pi by 2, like that. Then explanation of this property. See, suppose I am taking numbers whose product is less than 1. So tan inverse 1 by 2 plus tan inverse 1 by 3. I am taking x1 by 2, y1 by 3. Product of 1 by 2 and 1 by 3 is 1 by 6. 1 by 6 is less than 1. So this is allowed. It is equal to tan inverse 1 by 2 plus 1 by 3 upon 1 minus product of these two numbers 1 by 6. So this formula is allowed because 1 by 2 into 1 by 3 is less than 1. So this is tan inverse 3 plus 2, 5 by 6. 5 by 6 upon 6 minus 1, 5 by 6. So it is tan inverse 1. And tan inverse 1 is a pi by 4 because tan pi by 4 is 1. So tan inverse 1 is pi by 4. Suppose here now tan inverse x plus tan inverse y. Suppose tan inverse 7 plus tan inverse 1 by 7. Now I am taking here numbers whose product is 1. So here product of x and y is 1. So directly if product of these two numbers is 1, put value pi by 2. So this is equal to pi by 2 because 7 into 1 by 7 is 1. That is application of this property. Now here suppose I take x equal to 2 and y equal to 2, y equal to 3. So taking numbers such that product is more than 1. So here 2 into 3 is 6. 6 is more than 1. So applying this formula, it is equal to pi plus tan inverse x plus y upon 1 minus x into y, because 2 into 3 is more than 1. So whenever applying a formula, say here in all these three statements, tan inverse x plus tan inverse y, tan inverse x plus tan inverse y, tan inverse x plus tan inverse y, so which formula should be taken? So check condition of regarding given numbers. If product of given number is less than 1, choose this formula. Product of both numbers is 1, choose this second formula. If product is more than 1, choose this formula. So we have chosen this formula. So this is equal to pi plus tan inverse 5 by minus 5 minus 1. Now see, tan inverse minus 1. Tan inverse minus 1 is minus tan inverse 1. So this is minus tan inverse 1. So tan inverse 1 is pi by 4. So value is 3 pi by 4. Now this formula, product of x and y more than minus 1. If minus is given between tan inverse and tan inverse y, so tan inverse 3 minus tan inverse 2. So 3 into 2, 3 into 2, 6. 6 is more than minus 1. Obviously 6 more than minus 1. So applying this formula, it is equal to tan inverse x minus y upon 1 plus xy. So formula for minus tan inverse x minus tan inverse y. So this is tan inverse 3 minus 6 2 is 1 by 7. Now for this formula, explanation of 6 set. Suppose I keep here 1 by 2 or 1 by 3. 2 times tan inverse 1 by 2. Put 1 by 3. Now see, 1 by 3 is less than 1. Modulus of 1 by 3 is less than 1. So doing according to RHS, sine inverse 2 into 1 by 3 upon 1 plus 1 by 3 square. Applied first formula because 1 by 3 is less than 1. Modulus of 1 by 3 is less than 1. So used first formula. Or if you want value in terms of sine inverse, then use this formula. So this is equal to sine inverse 2 by 3 upon, this is 3 square 9, 9 plus 1 10, 10 by 9. So this is sine inverse 2 by 3 into 9 by 10. So it is sine inverse 3 by 5. Suppose 2 times tan inverse 1 by 3. Now if you want value in terms of cos inverse, then use this formula. So 2 times tan inverse 1 by 3, but before using that formula, check whether given number, does it satisfy this condition. So here number is 1 by 3 and already it is positive. So we are allowed. So cos inverse 2 times tan inverse 1 by 3 is cos inverse 1 minus 1 by 3 square upon 1 plus 1 by 3 square. So this is cos inverse 8 by 9 upon 10 by 9. So this is cos inverse 4 by 5. Two times tan inverse, suppose 1 by 2. Now you want value in terms of tan inverse, then use this formula. 2 times tan inverse 1 by 2 is tan inverse 2 into 1 by 2 upon 1 minus 1 by 2 square. So that is tan inverse 1 upon 4 minus 1, 3 by 4. So tan inverse 4 by 3. So that is application of these formulas.